First, I miss my lab. I don't miss winter, but I I miss my lab. I've seen a few of you in person over these months, but man, this is my first virtual thing. It's been like crazy childcare over these few months. So saw a few of you at Coxsci, but just made me miss seeing people in person that much more. All right, so the question I want to focus on is, where do our categories come from? And I want to give you a couple of examples supporting the idea that that language may be an important source for the categories. The common story in cognitive science, there's diversity of views, but the common story is that our categories reflect reality. So not some necessarily cosmically objective reality, but the evolutionarily adaptive reality. But nevertheless, whether they're innate or learned, the focus has been on the role of experience, perceptual experience, acting and being in the world. And when we think about the relationship of language, how language enters into this view, words map onto these pre-existing categories. So kind of here is a cartoon version of that. A person sees a dog, they have some concept of dog, and if they happen to have learned a language that has a word dog, that word, that lexical form maps onto this concept. Lila Gleitman has probably been the most clear in arguing for maybe a more extreme version of this view than many people hold, but still. And this is also the view assumed in a lot of how linguists think about concepts and semantics, where there's not a whole lot of work in linguistics about, where the categories that supposedly map onto words come from, right? They're just assumed to be there. And the words activate those categories. Okay, so the alternative is that without denying the first view that many of our categories come from kind of carving nature at its joints, the alternative is that many of the categories we learn, we may be learning from language itself. So if true, then differences in linguistic experience should lead to differences in thought. Now, what kinds of differences in linguistic experience? Here, the work over the decades has focused on different kinds of differences. So kind of following Worf, a lot of people have been looking at grammatical differences. I want to look at vocabulary. So no one doubts that we learn word meanings from language, right? But the question is, where do the categories that words supposedly map onto come from? Now, one straightforward prediction on the view that they just come from the world is that when it comes to things like perception, well, we all have the same perceptual systems. The perceptual world is more or less the same, right? We kind of all live in the same three-dimensional world at that level. And if you were at Stan DeHaan's talk, right, this is also a strong assumption in that work, that we have these geometric primitives that are supposedly innate. And so, we should all have similar lexical entries. And so this is a paper by Asif Majid and many other folks looking at coding of perceptual units in 5 modalities across 20 groups. And one result, this was kind of their main focus, has been that looking at which modalities are the most codable, finding that on average, there are differences. Color is on average more codable than smell, but there's a lot of diversity here. So there are languages in which people agree on what to call different tastes much more than they agree on colors or shapes. What that means in practice in these languages is that there are no conventional terms for things like square and circle and triangle. And so when shown a square, circle, and triangle, people tend to describe it according to its resemblance to real world objects. And so they end up not naming it the same way. They don't align. But even if you look at within the modality, so color, so this shows, based on some of our reanalysis, shows correlations between which colors are the most nameable. And these correlations are in general positive, but they're not very high. So what this basically means is that the regions of color space that are the most nameable vary, and what is nameable in one language is not necessarily nameable in another. So it's not that languages with fewer color terms just have larger categories. It's that in general, larger regions of the space in these languages with fewer terms are named conventionally. Okay, so what might be some consequences of such differences? So what kinds of differences in thought? The data I'll show you very briefly. We'll look at category learning and category induction. So this is joint work with Martin Zettersten, who's I think around on the call. So we start with the observation that looking at a single language within a language, there are large differences in color nameability. So everyone pretty much agrees. It's orange, red, blue, brown. You can give people other colors, and these are modal terms. They're not very good names for these colors because there isn't a really good name for this color. So this isn't a free naming task. Okay, and so what happens when you give people an objective category learning task? So here's a task. People see stimuli like these, and they have to learn to group them into category A, category B. And there's a simple rule that underlies these categories. The rule is if it has a red slice, it goes into category A. And if it's a brown slice, it goes into category B. That's it. That's the rule. And we can have the same structure, the same rule instantiated by harder to name colors. Now this is I think a 6-experiment paper. We make sure to control for perceptual confounds in every way possible to make sure that the colors are equally discriminable or even more discriminable in that low nameability condition. Nevertheless, there are very, very large differences in how easily people learn the rule. Okay, it's not just a color thing, so you can do this with shapes. So here are some nameable shapes. Here you can rotate them and to produce less nameable versions of that. Now all the low-level perceptual details are matched, and you get the same kind of effect. Okay. Now here we're only using a single language. This is not a very strong evidence of causality of language of differences in nameability causing these differences. So I don't have time to go through this work in detail, but we've also done tasks like this straight out of Stan de Haan's. So these are actually their stimuli from their paper arguing for core knowledge of geometry. So the task here is which of these figures doesn't belong? It's not timed. There's a normatively correct answer. So here, these are all squares. That's except the lower left, that's a rectangle. And these things differ in nameability. Okay, so here, everyone describes these rectangle versus squares. Here, people vary. It's harder to describe in English. And nameability is a strong predictor of people's performance. Okay, English nameability is not a strong predictor of performance of the Munduruku. We've also tested a few other groups. So here is a group, this is with Luis Bercia, Shawi, another Amazon horticultural group without conventional terms for shapes. Their accuracy is low. It's much higher than chance because, of course, they have a human perceptual system that can make all, it can tell whether there's one object or two objects and so on. And more importantly than accuracy, their performance is not predicted by English nameability. Okay, so the things that are nameable and easy for English speakers are not easy for the other groups. We can also do this kind of manipulation where we interfere with people's ability to name during the task. It's a very light form of verbal interference. People are just saying the while they do the task. And that decreases accuracy a little bit. But more importantly, it decreases the role of nameability. So in practice, what that means is that the items, the shapes that are most affected by verbal interference, they tend to be the same shapes, the same items that the Mundirku and Shawi, and there's also a group of home signing children here, have trouble with. So ordinarily, square versus rectangles is super easy for English speakers, and that becomes harder when placed under verbal interference. Whereas other kinds of more complex displays, different types of symmetry and so on that happen to not be nameable in English are not affected by verbal interference. They continue to be difficult. Okay, so rather than thinking about just categories reflecting some structure in the world, I want to argue that we impose a lot of the structure there with language. We don't invent language as individuals. We learn language conventions that have been invented by our ancestors because they're communicatively useful, presumably. And one way that language differs from the perceptual world is that language deals with the currency of language is categories and abstraction and combinatoriality, whereas the currency of perception, for the most part, are particulars. Right, and so what language, viewing it as a kind of categorical overlay, what it does is it now allows you to form a hypothesis like, oh, is it about redness? Is it about squareness? So that's one way of thinking about it. And so this is the last slide. The when thinking about language as a source of knowledge, the idea that we learn from language because people told you things, they told you that triangles have three sides. I mean, that's not in itself a controversial claim, but beyond these kinds of propositions, there is knowledge in the structure of language, and some talks that will follow will get more into that. But the other thing that I think has been somewhat underappreciated is that the vocabulary of a language, the basic vocabulary, what it does is it ensures that everyone becomes an expert in that domain. So a language with a set of basic color terms, shape terms, ensures that by the time there are 3 or 4 kids have aligned on squares and triangles and red things and green things in a way that absent that linguistic input, they might not, even though they're perceiving all of that same structure in the world. Okay. Thank you. And I'm at 15 minutes, so I'll just take one quick question, and so not to delay us any longer, and we'll go on to Rob.
If someone else has a question, then I have a question. But...
Me too, but I'll wait.
So I guess I can probably do one since I haven't done one yet.
Yeah, please.
So I'm interested in the, like, I mean, I guess I'm thinking what even is a category, right? Like, and it feels to me that there's like in your experiments, there's a lot of things that could easily be maybe explained by just being able to retrieve like distinction from memory more or less easily. And so so maybe this is more of a comment or a request for a comment. But if we're using presumably, if we have words, then if we have a word for something, we're probably sort of like in either in simulation or in some sort of practical way, like retrieving this distinction from memory more frequently than if we don't have a word for something, right? And so is that kind of a good way to think about what you think is going on here?
Yes. So learning a word requires learning a category, because you have to, at least if only for the purposes of speaking, distinguish between members of that thing and non-members. And that's not, you know, there's prototypical structure and all of that, right? But, and maybe you would do that anyway in the absence of learning a word because of the demands of your environment. But in some cases, maybe you wouldn't. There aren't perfect squares and triangles in the world. And so absent the need to learn the words, why would you learn that there is this abstract thing called triangle? This doesn't mean there is no way of learning it except through language. And there are nice examples of this, of, you know, abacus counting without necessarily counting a verbal number list. So you can have other technologies that take the place of a spoken or signed language. But language is just, it's something that ensures the members of the community will learn it and have it be ready at their disposal. Yeah.